This video continues Chapter 9 and will focus on sigma and pi bonds. There are two major types of covalent bonds. The first one is sigma and the second is pi. In sigma bonds, and the symbol we'll be using to represent that, you see before you, these shared electrons are going to remain in the area that is right between the two atoms. Single bonds are always sigma bonds. Here's a picture where we have two carbon atoms bonded together, and the space right between them is where the shared electrons are. This is a sigma bond because it's right between the two atoms. The second type of bond is a pi bond, and we use the symbol pi to represent that. In a pi bond, the electrons are going to be slightly above and slightly below the space that I showed you before. A double bond contains one sigma and one pi bond. A triple bond contains one sigma and two pi bonds. So notice that they all have one sigma, and then any remaining bonds are pi. Let's look at a picture of a pi bond. Okay, here you have carbons bonded together. This part right here is what we showed before. This is the sigma bond, and then here, if the electrons are in this space, that's your pi bond. So notice that the electrons are slightly above and slightly below the space right between the two atoms. Keep in mind that a single bond is made up of one sigma bond. A double bond is made up of one sigma and one pi bond. And a triple bond is made up of one sigma and two pi bonds. Okay, so they all have a sigma, and any remaining is considered a pi bond. In an example like the one you see before you, I could give you a Lewis structure and ask you to count the number of sigma and pi bonds. If we were to do that here, my sigma bonds, I have 1, 2, 3, 4, and then there's one right there, 5, so that's 5 sigma. And then recall that this one here in the middle was a double bond, so that has one sigma and one pi. So total, this Lewis structure has 5 sigma and 1 pi bond. In this example, we'll be drawing the nitrate ion and counting the number of sigma and pi bonds. When you draw a Lewis structure, the first thing you need to do is total valence electrons. Recall that nitrate is NO3 with a charge of -1. The nitrate ion will have a total of 24 valence electrons. And when you draw the Lewis structure, you will find that there are 2 single bonds and 1 double bond. To count the total number of sigma and pi bonds, for sigma we have 1, 2, 3 sigma, and then this remaining one is a pi, so 1 pi. Sigma bonds tend to be stronger than pi bonds, and they allow free rotation of atoms, whereas pi bonds do not. So for example, when you look at this picture that we have here, since that is a pi bond right there, these things cannot rotate around it, whereas here, that's a sigma bond, that carbon could rotate around that bond. Pi bonds are considered delocalized. This is a benzene ring, which you would talk about a lot in organic chemistry. It's not as common in this level of chemistry, but you see that you've got pi bonds here, here, and here, which is in resonance with this structure here, and the pi bonds are here, here, and here. So the pi bonds are able to move around the ring. We say that they are delocalized. But the main thing that you need to focus on is being able to count the number of sigma and pi bonds. When I look at this structure, for sigma bonds, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sigma. And then for pi bonds, that would be where our double bonds are. I see 1, 2, 3 pi.